Alright guys, so in this problem you have to determine the height of the flagpole, which is the distance from this point all the way up to the top. So that's what they want you to do. And you can see that there's two different types of triangles in this. One of them happens to be a right triangle. That's this triangle over here. And then the other one happens to be a non-right triangle. So that's your second triangle. So how are we going to use the info that they gave you in this, which which one of them is a 28-degree angle, one of the other angles is a 53-degree angle, and the distance from point P all the way up to point Q is 20 meters. So how do you use that to determine the height of the flagpole? Well, there's so many different ways you can do that. There's so many different ways you can get to the final answer, but I personally would do this. The fact that this is 53 degrees, I know that the remaining piece of this straight line has to be 180 minus 53, because you know that any straight line adds up to 180 degrees. So if you put that in the calculator to the right, that would be 180 minus 53, and that's going to give you 127 degrees, meaning that this angle is 127 degrees. Now you also know that every triangle has to add up to 180 degrees, so if this is 127 and the second angle in that same triangle is 28, you know that the final angle would be 180 minus the sum of the two angles that's given. So 127 plus 28, that's going to give me 155, and then you subtract this number from 180 to get the value of the remaining angle that would be at the top in the same triangle. So this right here would be 25 degrees. Now you're looking at this and you're thinking, well, why is this important? The thing is, if you think about this, if you're given a right triangle to the right of this same triangle that we're working with, if you're given this and they want you to solve for the height of the flagpole, they want you to solve for this distance, which I'm just going to call y, but again, it's really up to you whatever you want to call that distance. If you're going to need to solve for that, if I can find this distance, which is the hypotenuse of the right triangle, I can use SOHCAHTOA to get the height of the flagpole. But to be able to solve for the distance, I can't use SOHCAHTOA on this triangle. And the reason is because that's not a right triangle. So, that's a whole bunch of lines. Let me actually just redraw this triangle so it doesn't confuse you guys. So you got this triangle that's given to you. They're saying that this distance is 20 meters, this is 28 degrees, the angle at the top is 25, and this is 127 degrees. So what I really want to do is find this distance, because that's the hypotenuse in the right triangle. Once I can get this distance, I just have to apply SOHCAHTOA to get the height of the flagpole. So how do I go about this? Well, there's something called the law of sines that I can use to find this distance, and this is what we're going to do. I'm going to call this distance A, which would mean that this would be the angle A, and conventionally this is what we're used to seeing. Lowercase letters represent sides and capital letters represent the angles. So that's just one of the letters and one of the angles and one of the sides. To find this side, I'm going to say that this is side B, so that would mean that the angle that's opposite to this, meaning the 28 degrees, has to be the angle B. Once you can write this out, this is what you have to do. You would set up a proportion or write the law of sines, and that's going to help you get to the answer. A over sine of A is equal to B over sine of B. So what's the first side that we're going to be plugging in? Well, they're saying that the first side is 20 meters, so we're going to plug that in for A over what's the sine of A in this case? Well, since angle A is 25, we're going to say that this is sine of 25 degrees. And that's equal to side B, which we're solving for, so we're not going to plug anything in for that, over sine of B, which in this case is 28 degrees. Now what do you notice about this triangle? The measurements are given in degrees, and you're solving for trig functions, so it's really important that you make sure that the calculator is set in degrees. Depending on the calculator that you're going to be using, you would have to go into settings and change that. On the TI-84 and TI-83s, there's this key right next to the second key called the mode key that you can use to select the correct units that you're going to be using. So we're going to make sure that we're using the right units on this. So click on this, and then if you scroll down, you can see how it says radians. you don't want to be in this. There's times when you actually do want to be in there. But the thing is, right now you want to make sure that you're in degrees, and that's already highlighted. So you don't have to change anything to it. Second, quit so you can go back to the main screen, clear this out so it looks nice. What do you have to do with this? Well, let's just go back to the problem. We're solving for the side B in this case. So we have to evaluate the rest of the function. So this would be 20 over sine of 25. A lot of times you can just put the sine of 25. You don't have to close that parentheses, but I always do. It's just a habit. 0.42, and if you want to round that to 3 decimal places, that would give you 0.423 is equal to b over sine of 28. We're going to evaluate that the same way. So this is going to give us 0.469. 0.469. Alright guys, you can see that this is a proportion. How do you solve a proportion? Well, you can cross multiply at this point. So we're going to take the 20 and we're going to multiply that with the 0.469. And on the right, we're going to take the 0.423 and multiply that with the b to get that side by itself. Alright, so 20 times 0.469, that's going to give us 9.38 on the left, and that's equal to 0.423 b on the right. Now to get the b by itself, you still need to divide 9.38 by the 0.423. Now, if you notice in the calculator, I didn't have to retype the 9.38 because that was the last answer that was on the screen of the calculator. So I can just hit the division key and the calculator knows that the A and S represents whatever the last answer is. It's just like a quick way of putting that in and stuff. 0.423, put that in, press the enter key, and that's going to give you 22.175 again. If you want to round that to 3 decimal places, and since the units were given in meters, we're going to make sure that we put that. Keep in mind though guys, that's not the final answer, that's not what the problem is asking you to solve for, but this is going to help you get to the answer, of course, if you're solving a problem using this method. So I'm just going to box this so I know what that is. But why is it that this is important though? 22.175, how's that actually going to help us get to the answer? Well, if you go back to the original problem, let me just go back and erase this. Okay, so this is what they gave you, and the fact that we were actually working with this triangle, we actually ended up solving for this side. So this piece right here came out to 22.175 meters. Now in the original problem, what they want you to do is they want you to solve for the height of the flagpole, as you can see with the problem statement on the left. So if you think about this, if you look at the triangle that's given to you on the right, this is a right triangle. Okay, so we're going to draw this thing out. Okay, this is 90 degrees, and that's the reason why it's a right triangle. This is 53 degrees, and the hypotenuse is 22.175 meters. And you're solving for the height of the flagpole, which I think I said we're calling it a y in this case, but again, it doesn't really matter what you call that. The reason why this is important is because you can see that whenever you have a right triangle, you can apply right triangle trigonometry or SOHCAHTOA to solve for the value of the height that you're looking for, whichever distance you're solving for. But how do you actually go ahead and solve that? Well, the thing is, look at the angle that you're looking at, 53 degrees. How would you relate this angle to the side that's across from it and the side that's next to that? Well, we can say that the y would be the opposite, and then the 22.175 would be the hypotenuse. Now, which function relates the opposite and the hypotenuse in a right triangle? You know that that's the sine function because that's the first one that's in there. Sine of 53 is equal to opposite, which in this case is y, over the hypotenuse, which is 22.175. And this is going to help us get to the answer. Now, how do you actually solve this? Well, first thing I would personally do is put in the sine of 53 so I can simplify the term on the left. And that's going to give me 0.79 9 if you round that to 3 decimal places is equal to y over 22. Fix that real quick. Alright guys, so multiply both sides by 22.175 and that's going to give you the height of the flagpole. And if you round that to 3 decimal places, that's going to come out to 17.718 meters, since that's the original units that they gave you. Alright guys, this is the end of the problem.